Today, we are going to learn about what's called the standard apparatus and the Bunsen burner. You will need to know these things for when we come back. You will have to be able to put together both your standard apparatus and you'll have to be able to light a Bunsen burner. And if we don't come back this year, they're good to know for when you take chemistry in the future. So the first thing you will see on your worksheet, and this is what your worksheet looks like, is that these are the items that you would have found in your lab drawers. So these are the ones that we like to put on the quiz or on the test, the Unit 1 test. So just make sure that you know what these are, and these are the things that would be found in your lab drawers. Then we want to talk about what is the standard apparatus. And the standard apparatus is what we use whenever we're heating in the chemistry classroom. So the first thing that you would assemble is your ring stand. So first we would say the ring stand here. So if you're labeling it along with me, the ring stand is this large support bar and the supporting stand. So as you write that down, I'm going to go ahead and set this up. You take your support bar and the support plate and you put it in there, and then you're just going to give it a turn. Wonderful. So that is called your ring stand. Then the next thing that you need to place on your standard apparatus is the Bunsen burner. So you put the Bunsen burner on next, and it will have a flame on it. So the next is the Bunsen burner. Now, there is a very specific place in which you can put the two ring supports. The next ring support is actually going to be the small ring support. So the next one here is the small ring support. And as you write that down, I'm going to take our small ring support and I'm going to put it on here. Something that is very important when putting the small ring support on, and I'll probably put this as a lecture question, the small ring support has to be, and my mind's a little high, 3 fingers away from the top of the Bunsen burner. So when you're setting up your support, you make sure you have about 3 fingers worth of clearance. And you will understand why here in a minute. We need at about 3 fingers distance from the top of the Bunsen burner. So from the top of the Bunsen burner to the bottom of the small ring support, you need clearance of about 3 fingers. Okay. The next thing you will place is going to be your wire gauze. The wire gauze, which I don't know where that is. Wire gauze. Remember, the wire gauze is to efficiently distribute the thermal energy coming from the Bunsen burner, even for a nice even heating surface. So we have the wire gauze. Then the next thing you're going to put on is the large ring support. The large ring support. And depending on what size of beaker you're using, you might put it higher or lower, but we'll show you what that's for in just one second. Large ring support goes next. And then if you are heating, the beaker in which you are heating then goes on top. So I am an amazing artist. It's an amazing beaker. Beautiful. And the beaker is next. Okay. So the reason why we have the large ring support is if you start boiling something or if you knock it because you're using it as a hot water bath, the large ring support is to keep the beaker from getting an attitude and falling off. So the next thing that we need to do in the question here, it says, how would you remove a hot beaker from the standard apparatus? So let's say we had the flame on, we were heating something, we're done with it. How do you remove a hot beaker? Do you grab it with your paws? You do not. That's called a thermal burn and would require lots and lots of cold water. So what we're going to say, when you need to take something hot off the standard apparatus, you're going to use your trusty dusty beaker tongs. Not that this is not common sense, but I've seen people do it before. You don't want to grab it beneath the large ring support because then it won't come out. You're always going to pick it up over the large ring support and then you can remove any hot beaker. Okay. All right, so now we're on to actually talking about the Bunsen burner itself. So I'm going to zoom in here, so hopefully you can see our Bunsen burner. Before we ever light a Bunsen burner, or whenever Bunsen burners are on inside of our classroom, we always have goggles on and our hair pulled back. So that's even if we're just boiling water. You have to have goggles on and your hair pulled back whenever a Bunsen burner is on in our classroom. Okay, now we are going to talk about our Bunsen burner. Every lab drawer will have a Bunsen burner. We want to talk about that at the very beginning, how we get our Bunsen burner to light. There are valves around the room that say gas on them. I also have one on my front desk that says air. This one just pushes out air. Wonderful. Blows papers everywhere. But the one that we want to do is we want to always hook up the valve of our Bunsen burner after we've made sure that there are no cracks in the tubing. We are going to apply it to our gas valve. So you just take the end and you just slide it. It doesn't have to be super tight, but just snug. You're going to slide it on the end there. So what gas are we using? We are using methane gas, also known as CH4. So methane gas is what we're going to burn. Never mind that. And so the first thing I want to talk about, there are a few different ways to know if the gas is on and flowing. The first thing is that there is a gas on and off panel at the front demonstration table, and it requires a key to turn on and off. So I can always control the gas at the very front of the room. There is also an emergency shutoff near the door. If something were to go incredibly wrong and I couldn't make it up here, we can always hit it off and it can shut off gas to the entire room. On the other hand, if we are going to light our Bunsen burner, we look at the gas jet and we turn the handle so that it is parallel. And now you will probably hear gas is flowing. Again, the gas is on and flowing when the handle is parallel. The nice thing about these gas jets is that they can go both ways. So it is always on when it's parallel and it's always off when it's perpendicular. So on and off. So if we were asked, how do you know when the gas is on and flowing? When the handle is parallel, so this is off, on. Let's talk about the equation that we would need in order to efficiently light this Bunsen burner. So this has a little bit of chemistry in it that you wouldn't have to know yet, but we got to kind of balance the equation in order to make it understood as to why this has to happen. So it says, write the chemical equation in symbols and words of what is occurring in the Bunsen burner. So we said you take methane gas. Does anybody know what you need in order to burn? If you have a fire, it says you always need to cut off this in order to not let it burn. You always need oxygen gas. Does anybody know the two things that yield from combustion or burning? One of them is the thing that is very dangerous, which is carbon dioxide. And then the other thing is kind of sometimes surprising to some people, but you also produce water. So when you are burning propane or methane or wood or things like that, what you are going to do is you're going to take your whatever you're burning. It has to have oxygen, and you're going to yield carbon dioxide and water and maybe some other things depending on what you're burning. But natural gas or methane is very clean, and so this is the whole chemical reaction. Now it says write the symbols for this. So we said methane gas is CH4. And oxygen, you might remember from biology, is not just an O, okay? Oxygen is always written as O2. It's a diatomic molecule. We'll talk about that more later. And again, this doesn't have to be something you easily know. We're going through this to show you something. Carbon dioxide, hopefully you know, is CO2. And hopefully you know that water is H2O. Now, we're looking at this equation, and this is what we use when we are burning our Bunsen burner. Okay, that's what makes it burn. But the question here is this balanced? Is this efficient? And the one thing that you'll see is that there's one carbon on this side, and we always balance around the yield sign, and there's one carbon on this side. However, there's 4 hydrogens over here, and there is not 4 hydrogens over here. So what we need to do is we need to put a 2 in front of that, but then that gets me 2 oxygens here and 2 oxygens here for a total of 4 oxygens. So in front of this, I only have 2 oxygens here. So what I'm going to do is I'm going to put a 2 there. So now, never mind if you don't understand any of that, that is okay. We are not here learning how to balance equations today. We are learning how to light a Bunsen burner. The main reason why we needed to know this balanced equation is because looking at our starting materials, we have to have 1 part methane to 2 parts oxygen in order to have the most efficient burn that we can. If you have way too much methane and not enough oxygen, it will be an inefficient burn. And if you have more oxygen than methane, same difference. So this is really, really, really important that we want 1 part methane to 2 parts oxygen. So how are we going to do that? We're looking back up at the Bunsen burner here on your paper, or I'll zoom in here on my Bunsen burner. There are 2 controllers on your Bunsen burner. There are 2 controls. The first control is located on the side of the barrel here, and that is called the oxygen flow controller. The oxygen flow controller. All right, so now on your actual Bunsen burner, if we take a look at the Bunsen burner, the gas flows through this tube and into the Bunsen burner. And if you take this apart, which I wouldn't suggest doing often in class, you will see that there are some air holes in here. So when we turn this on, and this is where the gas comes out, I guess I should say. So the gas flows in through here and it comes out this tiny little hole at the top. So what the airflow controller is for is on the side. Let me line up these threads. Air can come in through these little windows on the side and pre-mix with the methane that's coming out. If you want more air, you let more of the window open. And if you want less air, you will close this Bunsen, the airflow controller. And if you see, as I'm threading it down, there's not as much transparency, and we can lock it all the way down here. Okay. So we have now closed off. No air can get here. Okay. So more air, we make the windows, more air is getting in here. More air is getting in here. The other controller controls the gas, and that is the gear on the bottom of the Bunsen burner. So the gas flow controller is here on the bottom. And so as the gas comes in through the Bunsen burner, there is a little gear here at the bottom. If you spin that, you can either allow more gas to come in and mix with the oxygen or less gas to come in. But remember that the overall idea here is that we get oxygen in methane in 1 part to oxygen in 2 parts. And we need to pre-mix that, and then we're going to light it at the top. So it has a very, very efficient mixture of, for every 1 methane, there are 2 parts of oxygen coming through here. All right. So again, if you couldn't see that up front, this is the air controller. And then this little gear down here is the gas controller. All right, let's light this and start talking about the different types of flames that you guys can possibly see here in this class. All right, before we get started talking about the actual flames, you are always going to use what's called a spark igniter. The way that this works is there's a little piece of flint that is going to be scraped over a little rumble strip that is on there, and you will light your Bunsen burner. You don't need those. All right, so here we go. So what we do is I'm going to make this the birthday candle flame first. I'm actually going to turn down this, turn that off. All right, so when we go to light, we are going to turn the gas on at the valve. I now can feel that there's gas coming out of it, and I'm going to light the Bunsen burner. I think that some of these are easier to see in the dark, so I'm going to turn off the lights. All right, so this is our first type of flame, and this is called the birthday candle flame. Looks like a very big birthday. Happy birthday to you. And the thing about the birthday candle flame, and please let you know that this is all relative, the birthday candle flame is not very hot. Now, it is on fire, so I'm not trying to say it's not hot. It is still extremely warm, but we can make it more efficient. What if you see the birthday candle flame? That means we need more oxygen. That means you have too much methane and you haven't gotten the 2 parts oxygen that you need. So what you will do, if you see the birthday candle, to show you it's not hot, I'm going to hold this piece of wire gauze in here. Remember, it's very efficient at distributing heat. And I hold it on there for a pretty long time, and it has not turned orange yet. Okay. It's not turning orange, as you can see. Okay. All right. So now what you're going to do to remedy, like we said, the birthday candle flame means that you need to have more oxygen. So what I'm going to do is I'm actually going to, on the sides, turn the barrel. And now we have what we call the big blue flame. The big blue flame is big and blue. Okay. And it's a little bit hotter, but it's not hot enough for us. We're closer to the perfect ratio, but we're not exactly where we need to be. So let me get my gauze as you're writing that stuff down. As I hold this here, there we go, there we go, there we go. Hopefully you can see now that this is getting to be pretty red hot. I don't know if you can see that, but it is starting to glow orange right on the end of that. Not super orange. We can probably get a little more orange, but this flame is much hotter than the birthday candle flame we had before. Perfect. All right. Then next, we're going to show you how to get the perfect flame. The perfect flame has a couple different parts to it. The perfect flame is extremely hot. It's as hot as it can get. And it has the perfect ratio of 1 part methane to 2 parts oxygen. And so if you want to shorten that up, you can say 1 part CH4 to 2 parts O2. You will know you hit that when there is a 3-finger tall, sharp inner blue cone. So what you will see is the flame might be kind of a little bit larger, but right inside here is a sharp inner blue cone that is 1, 2, 3. I'm amazing at drawing. There's your fingers. 3 things tall. All right, so what I'm doing now is I'm just going to bring down the gas, and I'm going to bring up the oxygen, down the gas and up the oxygen, and you can really hear when you have hit the perfect flame. And this is something that you would get your hands on and you would practice Wonderful. You hopefully can hear that rustling here. So what we're going to see here is right at the tip of the sharp inner blue cone. All of the extra kind of flame up here is hot, but what we are looking for is that sharp inner blue cone, and I want it to be relatively about 3 fingers in height. Okay, maybe a little bit taller. Now, remember, why is it going to be 3 fingers high? That is how far we put the wire gauze, which I have right here, from the top. Now, if I put the wire gauze right in the middle of that sharp inner blue cone, you will see it immediately starts to turn this wire gauze blazing red hot. Okay, super, super hot. So this is the hottest flame that you can get in this chemistry classroom. It has a sharp inner blue cone. 3 fingers high. It has 2 parts oxygen to every 1 part methane. Perfect. It has to have the sharp inner blue cone. So if I ask you what is the perfect flame, sharp inner blue cone, 3 fingers high. Oh, and the hottest part of that flame is right there at the top of that sharp inner blue cone. And that's why this is where your wire gauze will rest to evenly distribute the heat among here if you have a beaker that you are heating. Okay? That 3 fingers tall is not looking very good. All right, there we go. So hopefully you guys are doing well with this. Remember that the birthday candle flame is hot, but not super hot. As you start to get the right ratio, then eventually this needs to come down a little bit. That sharp inner blue cone is the hottest flame that we can get. All right, and then how do we safely turn this off? You would be surprised that some people try to blow that out. We don't want to do that. That's not good. What you want to do, because that leaves the gas going, what you want to do is you want to always take the gas at the gas valve at the wall and you want to turn it off. This then will be hot, so you can leave it out on the countertop to cool. But that is how you safely turn off the Bunsen burner. Now, sometimes in class, students in the back can't see the Bunsen burner that I'm working with. So we decided to dream a little bigger, and we decided to create a larger Bunsen burner. So I have some tubing with a stopper and a glass pipe in it. What I'm going to do is I'm going to take this end of the tubing, and I am going to apply it to our gas jet. And then I have a large glass tube. I'm going to take that end that has the gas attached to it, and I'm going to place it into the tube. And then what I'm going to do is I'm going to fill up this glass tube with gas and light it on fire at the end. Let's see how that goes. So I'm going to turn on the gas, give it a second, step away from my projector, and I'm just going to use an igniter today. And so we have gas flowing, and let's see. Wonderful. So what we have is a giant Bunsen burner. If I had a really long tubing, I could probably stand in the hallway and greet my freshman advisory. Hello, freshmen. No, maybe they wouldn't like that. Okay. So as you can see, what type of flame is this? This is the birthday candle flame. So what that means is that I need to add more oxygen. So because I have on this end, I simply have nothing but gas coming in. All we have is we don't have any premixture, and the only place that the gas can burn is at the very top where it's meeting the oxygen. So I'm not worried about the tube itself catching on fire because down here is just gas. The other thing is the thermal energy to burn is at the top. So what I'm going to do is I'm going to pre-mix down at the bottom. I'm going to kind of pull away the stopper so I can not only get gas to come in, but I can also get oxygen to come in, and it will mix along the glass tube, and we should see a more bluer, hotter colored flame at the end once I do that. Little note, it does get to be a larger flame before it gets to be bluer, but I'm okay. I have my goggles on. So what I'm going to do is I'm just going to loosen the end here, And I'm going to pre-mix some oxygen because remember, more gas isn't always the answer. You need 2 parts oxygen to every 1 part gas. So the flame's going to get a little large. We're okay. Then, now what I have done is I have pre-mixed. So now I have more oxygen going in with the methane, making a bluer, hotter flame. And you're like, well, that doesn't look as much fun. And I know that the birthday candle flame is large and it looks fun, but this is a much hotter flame. I'd let you touch it and tell the difference. No, I'm just kidding. I would never let you touch it, even if we were in class. So what we can do is we can starve it again. Now that oxygen is being used up. There we go. We're back to our orange flame. And again, if we want to start getting a hotter, bluer flame, whenever you see a birthday candle flame, all you have to do is add oxygen. So I'm adding oxygen now here, down here at the bottom, pre-mixing oxygen in with the methane. Again, 2 parts oxygen to every 1 part methane makes a blue, hot flame. Wonderful. And sometimes what we can get this to do is we can get the flame to actually chase down the tube. I'm not sure if I'm going to be able to get you guys to see this because it is a very slight thing, but I'm going to turn off my projector. And if you take a look at the tube, usually you can see it at the top, we should be able to see a blue flame hopefully run down the tube. Once I remove the methane and just have the oxygen, it will chase the oxygen down. Ready? Let's see. And it's going to get large first. Nice. I don't know if you could hear the little whoo sound. Maybe I need to move the microphone a little closer. All right, so let's try that one more time. Ooh. Turn on the gas there, genius. Sorry. All right, so let's try that one more time. I'm encouraged that we could really see that. Beautiful. But you could hopefully see, I think I can see it on my camera. Hopefully we can see that blue coming on down, and then it makes a whoo sound as it goes down. I don't know if you can hear it, but I'll find out in the editing. So again, big yellow flame, big orange flame, not very hot. But what we're going to do is we're going to add some oxygen. If we then take away the methane, and I'm going to take it out of the end here, and then it should chase down and make a pretty cool sound. 3, 2, 1. Flame gets bigger. I don't know if you could hear that. It's so quiet. All right, one more time. 3rd time's a charm. All right, let's try it. I just love doing this demo. I don't know. Woohoo! You know, maybe at trick or treat time, be like, hello, kids. I don't know. You know, whatever. Makes my neighbors feel welcome. So here we go. Let's try this one more time. See if we can't get the blue flame to chase down the glass pipe. All right. I think that's about as good as it's going to get.